Hello, everybody. Welcome back. Hope you guys are doing really good and had a good weekend. So yeah, we got another new lesson coming today. We're moving into the second half of the semester, and we can go over the midterm a little bit today. That'll be the first thing that we deal with. Then we'll start to learn some new topics and just chart our way forward for the next few weeks. So hope you're all doing really well. It's about 2.5 minutes, and then we'll get going. But of course, as always, feel free to say hello if you'd like, if you're here. I always appreciate seeing you guys, checking in when we have these meetings. Hey there, Stephanie, John, Rev, and Jessica. Good to see you guys. Hey, Leo. Just another minute, and we'll be good to go. Just looking through these old notebooks in case I have this one note in here. Hey, everybody. See you guys. Good to see all y'all. Hey, Rachel, Valeria, everybody else. Hey, Ruby. All right. Well, we're pretty much good to go. All right, guys, welcome back. Good morning to everyone. Thanks for being here. So today we're going to just do a couple of important things. We want to start off by going over some of the material on the midterm. I'm going to send the answer key around, and you'll be able to check that and compare your exam submission to it. But I'll also be done, scoring them all individually by the end of the week. But in the advance of me completing the full grading task, I do want to just go over all the correct information with the class as a whole one time right here. So let's go back over the midterm information, and then when we're done with that, we'll start on a new topic in our class as we start learning the all-important concept of how to do proofs and derivations in logic. So the whole second half of the semester is really just all about learning how to do proofs. But let's take that one step at a time when we get there, and we will talk about it. So what I'm going to do now, as I've done in the previous few meetings, when we've had some group work or some activities that we all want to focus on, I'm going to put this link for a Zoom meeting here in our chat. That allows me to record this and still show you guys a screen share, so I can pull up the midterm test form and demonstrate some of the correct information on the board. So 1 second really fast. Okay. So here is a Zoom link. You see it there. Go ahead, click that one, and I'll open that meeting right now. Okay, cool. I see you guys. Sorry, am I muted? Am I unmuted? Can you hear me? Just double checking if my audio's working correctly. Okay, thank you. I see the chat, and I see that you've given me the yes answer. So let me share the screen. Wait, I am the host. I don't understand. A little strange. Okay, hold on a second. Let me leave the meeting and come back to my own meeting. 1 second. I have to do a login thing, so there's a little dual authentication that they want. Okay. All right, here we go. Now we should be in better shape. Screen share. Okay, sharing the screen. And so, all right, guys, sorry I had to come back, but now we're all, I think, in the right place. So just one time, let me check with you. Can we see the chat and the screen share and you hear me? Okay, thanks so much. All right, so I'm gonna start off at the top and we're gonna go over these true-false questions together. So let's see if we have a sense of the correct answers and why. Now, obviously on the test itself, all you had to do was circle T or F. You didn't have to provide the explanation on the exam, but now that we're here to talk about it, we will. So the first question, it says this. Is this true or false? Any argument that has true premises and a true conclusion is valid. Is that true or is that a false statement? Is it true that if an argument has true premises and a true conclusion that it must be valid? Is any argument like that valid? Good. False. The correct answer is that that is false. So you can have an invalid argument where all the premises and the conclusion are true. All that that requires is that the conclusion is not something that is implied by the premises. So like, for example, here's an invalid argument where every statement is true. Dr. Vulich lives in California. Therefore, Dr. Vulich is a professor. It's true that I live in California. It's also true that I'm a professor. But just because I live in California, that doesn't force it to be true that I'm a professor. We can clearly imagine a possible world, not this one, but a different possible world where the premise is true and the conclusion is false. Suppose that I did not get into grad school and I just became a high school teacher, which probably would have been my plan B, okay? In that case, I still would have been from California, but I would not have been a professor. So that's an example of an argument which is invalid, but all the claims, premises, and conclusion alike are true. The definition of validity does not say that the premises and the conclusion are true. It says that it's valid in case it is not possible for the premises to be true and the conclusion false. But in the case I just mentioned, though all the statements are correct and true, it is not impossible logically for the premise to be true and the conclusion false. So correct answer for number 1 is F. Let's go to number 2. Number 2 says all valid arguments have true premises and a true conclusion. Okay, so it's a similar wording to question 1. But let me know, is every single valid argument have true premises and a true conclusion? True or false? Okay, I see Ruby is saying, okay, false, false, good. The answer is that that is false. It is false. It is not true that all valid arguments have true premises and a true conclusion. It's just not. So consider valid arguments where the premises and the conclusion are not true. Okay, like here's an example. All human beings have traveled to the moon. Let me think of who's a prominent human being that we all know. LeBron James is a human being. So what would be the conclusion? The conclusion would be that LeBron James has traveled to the moon. Now, is that argument valid? Yes. But does it have all true premises and a true conclusion? No. It's a valid argument because it is not possible for those premises to be true and the conclusion to be false. Supposing that the premises are true, the conclusion couldn't be false because the premises basically just affirm the information that the conclusion states. So it's just not true that every valid argument has true premises and a true conclusion. To assess validity, you have to examine the premises and the conclusion and actually look at what they say. So you need more information than just knowing what their truth value is. You need to be able to analyze whether or not there's any possible world where the premises are true and the conclusion is false. So you kind of have to like take view of the possible situation where the premises are true. Then you have to ask yourself, in that hypothetical situation or reality, could the conclusion be false? If so, it is invalid. All right, so question 1 and question 2, the answer of both is F. Next up, question 3. All sound arguments have true premises and a true conclusion. Is this true or false? Question 3. Okay, Evelyn, Frida, true, true. Tanya, true. Good, it is true. The answer of number 3 is T, it's true. Every sound argument has true premises and a true conclusion. Why? Because a sound argument is what? It is a valid argument where all the premises are true. So if it's valid, that means that it can't be that all the premises are true and the conclusion false. Since it's sound, the premises actually are true. And given that the argument overall is valid, that means that the conclusion cannot be false. So every sound argument is valid, plus everything in it is a true to reality fact. So number 3 is just true. Okay, number 4. Every valid argument that has a false conclusion must have at least one false premise. What do you think on number 4? Is that true or false? Every valid argument that has a false conclusion must have at least one false premise. True, 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 true. Okay, exactly, yes, that is correct. If the argument's valid and the conclusion is false, it cannot be that every premise is true, because if it were, then that would mean that the premises are all true and the conclusion false, which is the definition of invalidity. So given that that the conclusion is false, must have at least one false premise. So like an argument where the conclusion is LeBron James has visited the moon, if that's valid overall, then at least one premise has to be false, like a statement that says all human beings have visited the moon. Okay? Good. So question 5. Every argument that has a logically true conclusion is valid. True or false? If the conclusion is logically true, it's valid automatically. Is this true or is it not true? Okay. Seeing a combination of true and false responses given by different students. But this one, I was hoping to see more unanimous response. It is true. It's just one of the special cases of validity, which we've all learned. There's 3 special cases of validity. When the conclusion is logically true, when at least one premise is logically false, or when the premises form a logically inconsistent set of statements. So when the conclusion is logically true, that means that it is guaranteed that the premises cannot all be true and the conclusion false, because having the logically true conclusion blocks the conclusion from ever having the value of falsehood. Therefore, it cannot exhibit the combination where every premise is true and the conclusion is false, since the conclusion simply cannot be false if it's logically true. So number 5, the correct answer is T. So if you're looking at it and going down, we have F, F, T, T, T. Okay? 2 F's, 3 T's, now we're on to number 6. Number 6, it asks this. Well, the statement says, the following is an argument. If I ace this exam, then I will celebrate. True or false? Is that an argument? Tanya says false. Many of us are saying false. Okay, good. That's the correct answer. Who can tell me why is that not an argument? The sentence that says, if I ace the exam, then I will celebrate. Why is this not an argument, since we all seem to know that it isn't? How do you know that? Why not? What's the reason you gave that answer? Because it is only one sentence, exactly, Natalie. And what do we know about arguments? That an argument has to have, at a minimum, 2 sentences, because every single argument has a conclusion and minimum of 1 premise. So there's no such thing as an argument which is a single sentence alone. If I tell you that the earth is round, that's a true statement, but it's not an argument. An argument has to have some stated premises which are given as reasons or evidence leading towards the conclusion. So any sentence by itself, whether it's true, whether it's false or anything, is not an argument. To have an argument, there must be at least 2 statements where one is a conclusion and at least one of them is a premise. Okay, good. So now moving to number 7. Maybe I'll put this here on the board while we're looking at it. Okay, so number 1, F. Number 2, F. T, T, T. Number 6, false. Okay, so that's the breakdown so far of the correct answers. Now I'm looking at number 7. Here is the question. If the premises of an argument form a logically inconsistent set, then the argument is valid. Is this true or false? Say we have an argument, the premises cannot all be true. That's what it means, that they're inconsistent. So does this mean it's a valid argument? And you're telling me true, and that's correct. Yes, good. When the premises cannot all be true, meaning that they're inconsistent with each other, then that's a valid argument automatically for one of the 3 special cases of validity. In that case, the premises can't all be true. According to the definition of inconsistency, if they're inconsistent, that just means that they cannot all be true. And if they cannot all be true, then you cannot have the required combination which exhibits that it's invalid, namely every premise being true and the conclusion being false. If the premises can't all be true because they're inconsistent with each other, then you'll never have the required combination which exhibits that it is an invalid argument. In other words, it's not possible for an argument with inconsistent premises for the premises to all be true and the conclusion false, for the simple reason that with the inconsistent premises, on that basis alone, they cannot all be true. Okay, so question 7, if they're inconsistent premises, is it valid? Yes, true. Number 8. Okay, so question 8 is all about consistency, and here's what it says. The following set of sentences is logically consistent, and here are the 3. Cal State Fullerton won the 2006 College World Series of Baseball. Australia is currently at war with Canada. And number 3, Venus Williams is an Olympic soccer player. So take that set of statements. Are they logically consistent or not? Is it true that those are logically consistent, or is it false? Let me see in your response in the chat. Question of number 8, consistent, yes or no? True or false, consistent? For question 8. Okay, Frida, Samir, Stephanie, we're getting the answer that that is true, and you're correct. Those are consistent statements. Why? Because none of the statements contradicts or invalidates any of the others. Are they all actually true? No, because as you guys know, Venus Williams is a professional tennis player, and Australia is not at war with Canada. But these 3 things could all be true in some possible world. It's not impossible within the realm of possibility for those 3 things to all occur in the same world. And since they could all be true, in theory, possibly, they're logically consistent. The only time sentences are not consistent is if there's just no even way to imagine all of them being true. But these things, picture that, it's like a scenario that could occur. Had those things all been true, which could have happened but didn't, then they would have all been true, and it's therefore consistent, okay? So number 8 is true. Okay, number 9. Question. It says all logically false sentences are equivalent logically to one another. Is this true or no? True or false for number 9? Again, the question is, or the statement is that all logically false sentences are equivalent to each other. Is this correct or not? True or false? Number 9. What do you think on number 9? Let's see it. Okay. Many people saying false, some saying true. So there's a divided opinion in the class. Well, The correct answer is that it is true. Okay, it's true. To somebody who knows that this is true, tell me why. Why is it that all logically false sentences are equivalent to each other? They are. Why though? Because they cannot have different truth values. Perfect, exactly, Lily. If they're both logically false, then that means that they cannot be true. So there's no possible world in which a logically false sentence is true. Therefore, take any two logically false sentences that you like, and they are equivalent because they always share the same truth value, namely F, namely being false. So when two sentences are not equivalent, that means that there is at least one possible world where they have different truth values. But two logically false sentences are false in every possible world, and therefore they never have a difference of truth value. So like 2 + 2 = 9 has the same truth value as there are 7 sides on a triangle. They're both logically false. There's no case where either one is true. So there's no possible world where one of those two statements is a true statement and the other one is a false statement. They're both false in every given scenario. So they must be equivalent. Okay, so number 9 is that it is true. And now to number 10. All logically indeterminate sentences are equivalent to each other. Is that true or false? All logically indeterminate sentences are equivalent to each other. This is true, this is false, definitely false. Okay. I see a couple of people giving their thought on this. Yes, good, Tanya, false. All right. And you're right. The answer is false. It is not true. It is false. 10 is false. Not all logically indeterminate sentences are equivalent to each other. All right? And it's easy to understand why. Take these two logically indeterminate sentences. I'm a professor at Fullerton. You, whoever you are listening, are a student at Fullerton. Now, are those two things true in this actual world? Yes. But is there a different possible world where only one of them is true and the other one is false? Sure. Suppose that you had not gone to college and just decided after high school, I want to just work. Then that would be a possible world where yes, I'm a professor, and no, you're not a student here. So though these two things happen to be true in our world, they don't have to both be true in every conceivable world. And since there's a conceivable case where one is true and the other is false, they are not equivalent. Any two logically indeterminate sentences can have a lack of equivalence in the same way. Okay, so it's only logically true sentences that are all equal to each other and logically false sentences that are all equal to each other. When it comes to a logically indeterminate sentence, you would have to look at the individual example more closely. You could not determine or infer just from knowing that it was indeterminate that the two statements were equivalent. They may or may not be, but it would depend on the actual information that they contain. So number 10 is F, false. Okay, so these would be the correct true and false responses for the first 10 questions on the exam. And that's worth 20 points. It's 2 points for each correct response. So, you know, a person who got all 10 of these, they're starting their exam with 20. And the person who misses all of them or whatever, some combination of them, you deduct 2 points off of the 100% for each wrong response here. Okay, so let's go down. Next, there's the definition section. And there's just those 2 questions in that part of the test. So let's get on to that. How do I finish the statement? An argument is valid if and only if what? Let's see that one in our chat. What makes an argument valid? It's deductively valid if and only if, just in case, Frida, good. It is impossible for the premises to be true and the conclusion to be false. Exactly. So an argument is valid if and only if it is not possible for all the premises to be true and the conclusion false. Some may have stated it in the way of if the premises are all true, then the conclusion has to be true as well. I would also accept that as a fine answer. So those are both equivalent ways of stating this definition. So important point, when it's valid, you cannot have every premise true and the conclusion false. Okay, good. So then we talk about 12. A sentence is logically indeterminate if and only if, Tanya, it is neither logically true nor logically false. Exactly. You could also say if it is possible for it to be true or false, or something along those lines. But those would both be fine and decent ways of putting the point. Okay, so we go down to the symbolization section. All right, so those two are each worth 5. Since everybody had access to their books, I would really hope that nobody had to miss these questions, because all you really had to do is just go to the book and find the stated definition or go to your notes. Symbolizations come next. Okay, so there's 6 questions in this part, 1, 2, 3, 4, 5, 6 of them, and they're each worth a total of 5 points. 6 times 5 is 30. So we've gotten past the first 30 points of the exam here, and now we get into the next 30, which is the symbolization category. So let's do these, starting with 13. Okay, so in the same way we've always done it, you have to start off any translation from English to logic by creating a symbolization key. So let's do that with question 13. Let me get a sentence letter. Okay, so we're already going there, Tanya. A, Athos will rescue the queen. Okay, Athos will rescue the queen. And let's see what's next. M, Aramis engages the cardinal's guards. Okay. Okay, Aramis engages the cardinal's guards. And then P for Porthos, yes, engages the cardinal's guards. Okay, so we've got the letters that we need, A, M, P. So now the question is how to state this in the logical symbolism that we have using these letters and the connectives. So 13, Athos will rescue the queen if either Aramis or Porthos engages the cardinal's guards. So who could take an attempt at reformulating this into the logical parlance that we're using, SL, starting with the left of the expression and then through to the right. So it's just one sentence in logic. How can it be written? Let's see here in the chat if anyone could give us the answer, and I'll work with what we've got. Okay, so close, but both are not correct actually. No, they're close, but there's one issue. Can we see another attempt? Anybody? Okay, good, Lily, that's right. It's the disjunction that is the antecedent. A is not the, yeah, so A is the consequent, not the antecedent, that's right. So here we go. If either Aramis or Porthos engages the cardinal's guards, so if either M or P, then in that case, A. This is the correct order because you have to remember that when if appears in the middle of the statement, the information that follows to the right of the word if is the antecedent of the statement. And I mean, that should make sense to you because it says that Athos will rescue the queen if either of those two events happen. So, in other words, if either Aramis or Porthos engages the cardinal's guards, then in that case, Athos will rescue the queen. It's like if I say to you, I'll hurt my knee if I fall off my bike. That means that if I fall off the bike, then the knee will be hurt. It doesn't mean that if I hurt the knee, then I will fall off the bike, right? So when the single word if appears in the center of a proposition, then whatever falls to the right of that word if becomes the antecedent of the relevant conditional. Okay, so the antecedent is the disjunction statement. If either Aramis or Porthos engages the cardinal's guards. And the consequence that comes from that disjunction is that Athos will then rescue the queen. Okay, so 13, you have to have the correct parentheses bracketing the disjunction here so that we see that this whole thing is the antecedent and not, for example, just the letter M disjoint to P then A, right? Could P and M be switched? Okay, good question, Jessica. Yeah, that is fine. When it comes to the order of two disjunctions, or even two disjuncts or two conjuncts, they can be either direction, left or right. So that does not matter. Yes, that's fine. Okay, so like this could have also said P or M, then A, and that would have also been no problem. Okay, good. So this here, if this information was written in your test, you get 6 points for this one. Okay, and of course there's possible partial credit for if there were some errors, but it depends on how flagrant the error was or how far away it was from the right answer. Okay, so now to 14. So in question 14, let me scroll here to it. You see it? Let's start off by creating our symbolization key as we always do. So T then will stand for the tobacco tax comes up for a vote. Okay, and R, let us say it in a full, complete sentence rather than use the pronominal it, so the tobacco tax is repealed, that's R. Okay, and then we still need one more. S, smokers will pay less money for cigarettes. Good. Misspelling, thanks. Cigar, 1R, cigarettes, okay. Okay, so these are the sentence letters involved in the formula. And then now we just got to put it all together. So if tobacco tax comes up for a vote, then if it is repealed, then smokers will pay less money for cigarettes. How does this get symbolized into logic? Okay, so Tanya, you're going with T, if T then R then S. But the parentheses are a little off, actually. Drawn red, no, it's not a conjunction. The main connective of the statement is the arrow. It's a conditional statement. So, Lily, there we have it. T, then if R, then S. Okay, because like if you look here, the statement says if the tobacco tax comes up for a vote. That's the original antecedent of the main connective conditional. What follows after it then is another conditional. So the consequent of the main conditional is like a nested conditional itself. So the consequent here, clause, is a full conditional, which will appear exactly as Lily's answer. So this is just T, then parentheses R, then S. If the tobacco tax comes up for a vote, then if it is repealed, the smokers will pay less money for their cigarettes. So in case this thing comes up for a vote, then in that case, if the repeal happens after the vote, then the smokers will pay less money for the cigarettes because they would repeal the tax and then they would be paying less money. How many points would be off if it was T then R then S with the brackets around the first part of the expression? It would be a little bit of points off, maybe a couple points. Yeah, because you do have to make sure to group things appropriately and make sure that the correct antecedent is designated. But you would not miss all the credit. You would just miss some of it, maybe like a third or something like that on that question. Okay, so there you go. And yeah, so next we talk about question 15. All right, so if this was your answer for 14, this is 6 more points. All right, so now to number 15. All right, to start number 15, we once again go over the symbolization key. So Frida, you're giving C, Cliff will get the job. Okay, good, gotta start somewhere, and that's a good place to start. So with letter C, and we still need a couple of other letters. So what else? C is one piece, but there's more pieces to this puzzle. So what else? Number 15 is the question. You can hear me, right? Is there any problem with the chat? Okay, good, Brenda. R. Raul writes Cliff, because the pronoun him makes it an incomplete sentence. So R, it's Raul writes Cliff a letter of rec. Okay, and then also J for Jin writes Cliff a letter. CRJ. Okay, now let's see what is the answer on this one then. We've got the sentence letters given. There's our 5 logical connectives. So what's the correct order of symbols in this given case? What do you have for me? Okay, C, then both R and J. Perfect, yes. That is correct, Frida, and that's also correct, Evelyn. Cliff will get the job only if a conjunction of 2 facts, only if both R and J. If both Raul writes in the letter and J. Now, notice this, that because it is the word only if, instead of just if, we then interpret the right-hand part of the sentence as the consequent of the material conditional. Each question in the, Jamie, in the translation section are with 6 points. Sorry, I meant to say 5. Thank you. Yeah, because there's 30 points total. You can just do the math. 30 points, 1, 2, 3, 4, 5, 6 questions in that section. 6 times 5 is 30, yeah. So they're 5 points each. I'm sorry if I said something incorrect earlier, but they're worth a maximum of 5 each. Now, what I was just trying to explain is the difference between the words only if when it occurs in the middle of a sentence and the single word if when it occurs in the middle of a sentence. Now look, without the attached word only, this is going to be interpreted as the antecedent, namely the thing that is on the left of the arrow. But when the word only is attached to the word if is different than regular if. With only if, we simply read it left to right in the order that the sentence is written. So that is why C is to the left of the arrow in question 15, but M or P is to the left of the arrow in question 13. So you just have to be alert to whether it says if or it says only if. And then yet again, something different from either of those is if it says the exact phrase if and only if, which is not the same as regular only if. Only if by itself is the single arrow. If and only if is the double arrow. And so like some corrections on homework 2 were involved with that, little piece of logic. So anyway then, this is our answer for question 15. Cliff will get the job only if both Raul and Jai-Jin write him letters of recommendation. Okay, so sorry for what I said earlier about 6 points, but yeah, this would be another 5 for anybody who got it correct there. Okay, so question 15, we're good to go. Let's look next at number 16. Okay, question 16, yes. Here we go. You're seeing it displayed on the screen right there. So let's go over this one. First, let's get the symbols in our symbolization key. M, Maria gets the job. Okay, good. Okay, and then we have D for Diego gets the job. And C for Cliff gets the job. And well, there's still one more thing. Yes, Cliff applies for the job. Good. So C, Cliff gets the job. A, Cliff applies for the job. Okay, MDCA, 4 letters to use. Now we just got to translate this statement here. Neither Maria nor Diego will get the job, but Cliff will if he applies. So let's see, take a stab at that. What is your best attempt to answer this one? I'm looking in the chat and I'm just seeing what your answer is for this. Okay, Frida. Well, almost Frida, but there's a few errors in yours actually, so no. And then Lily, yours is perfect. That is correct. Okay, so first thing, Frida, let me say this. To say neither, we gotta all remember how to say neither. I've seen too many cases where the person writes a negation in front of a conjunction. That is not neither. Neither is a negation in front of a disjunction. Just look at the word neither. The letter N is prefixed to the word either. It means literally not either. Not the case, that either. Not the case that both expresses a different fact. If I say to you that neither Trump nor Biden will win, that means that I somehow think that like Kanye or some other person is going to win the election. If I say not both will win, that just means that they're not both going to emerge victorious. One of them will, but not both. So to say not both leaves open the possibility that one and not the other. That's what a negation of a conjunction means. But to say not either means it will not be either case. So what's logically equivalent to not either, the negation of a disjunction, is a conjunction of two negations. So you could have said both not M and not D. But then the negation symbol would not be on the outside of the parentheses. It would be attached to the two letters within the conjunction inside of the parentheses. So that's the error there, Frida. But Lily, you have the right answer. It's this. It is not either M or D. But, okay, this is the conjunction sign, but maybe to make sure that it's very visually clear to you, I'll use the ampersand, the classic conjunction sign. But Cliff will get the job if he applies for it. So if he applies, then Cliff gets the job. And there you have the full correct translation. An alternative to this that would have received the same full credit is to state it as a conjunction of two negations. So not M, both not M and not D. And, well, I'll be consistent. And if A, then C. So either of these two would have been a fine answer. But what you did have there, Frida, is this, which is wrong. That's not okay. This is the specific way to say neither. Or if you prefer, I mean, a little more complex symbolism, but that's also logically equivalent. Okay, so question 16, everybody. And at any point, as always, just let me know if there's anything I can clarify or go back over if you need it. So question 16, we're good on this. Symbolization key and the translation. Okay, so next up, we look at question 17. All right, so as always, we need to start with the key. So let's get that out there. What can be used in terms of designating sentence letters here? A, Arnold will be the next governor. All right, great. Okay, and I guess you're going with R for Villaraigosa decides to run. Let me see here. Yeah, okay. And then one more letter. V for Villaraigosa will be next governor. Okay, good. A, R, V, 3 letters. Good. So that much is now all done. But now the next part, putting it together and translating sentence there. So Arnold will be the next governor unless Villaraigosa decides to run. in which case Villaraigosa will be the next governor. So what can we put together here? Let's see. Go ahead. Let me see your answer, at least the attempt. Okay, so Giselle, you have A, unless if V then G. But no, because like, first of all, your conditional there on the right says that if Villaraigosa is the next governor, then he'll decide to run. But that's kind of getting it backwards, right? I mean, you don't, becoming the governor is not the cause of you running. It's the other way around. Because you run, then you might win. It's not like if you win, then you might decide to run. That's getting it reversed. We can see, right, what the thing that starts it and what the consequence is that comes from that. So let's see here. Also, I'm sorry, Giselle, but your lettering there, the letter G, I know that you must have intended the other one that's available in our key, or maybe you're referring to the one that you designated in the work, but we are limited to A, R, and V. So let's see, Evelyn, what you have, A or R. So Arnold will be governor unless Villaraigosa decides to run, good. And also, if he decides to run, then he'll be the next governor. So that's perfect. Both the answers here written by Evelyn and Valeria, those are both accurate and correct. So I'll put it here. A unless R. Also, if R, then V. Okay, this one closely mirrored an example that was placed in your homework problems, like Clinton will be next president unless Sanders decides to run, or unless Sanders wins California primary, in which case he'll be the next president. So in which case expresses the content of a conditional. It says that in case Villaraigosa decides to run, then in that case, he will be the next governor. That conditional is conjoined to the statement that Arnold will be the next governor unless Villaraigosa decides to run. Okay, so unless is symbolized just with the disjunction sign or the wedge. So anytime you see the word unless written, you translate it by means of wedge. So A wedge R means Arnold will be governor unless Villaraigosa decides to run. In case he decides to run, then he'll be the next governor. And the only relation between these two separate facts is that they're conjoined. Okay, so yet again, one correct answer for question 17, worth 5 points if you have that. And then let's go to 18. Okay, so question 18 then. You see it there in the chat. Maybe this one was a little tricky, but let's get the letters going. So J for Jaejin will graduate. Okay, good. Jaejin will graduate. I, Jaejin insults the dean. Okay. C, Jaejin fails her chemistry exam. Good. Okay, J, I, C, and H for she fails her history exam. Good. Okay, J, I, C, H. Now, all that left is to translate the statement. Okay, so Jaejin will graduate unless either she insults the dean or fails both chemistry and history. So how do we say this? She'll graduate unless either of one fact or a conjunction. So go ahead, let's see what even if it's just one attempt, we'll correct it as necessary. Okay, Brenna, you have that J or I or CNH. Okay, good. Let me just double check it. Jejin will graduate unless. And then we have the disjunction. The disjunction is she insults the dean, or two things both happen, that she fails chemistry and history. So that's exactly correct. I'm just double checking how many parentheses you have on the left and right, but that looks correct to me. Okay, so Jejin will graduate unless all of this next stuff occurs. Unless either she insults the dean or fails these two things, chemistry and history. There you have it. Graduation happens unless either there's an insult given to the dean or she fails these two classes. So it's like, suppose she fails these two classes and doesn't insult the dean, then she won't graduate. Suppose she insults the dean and she still passes these two classes, well, insulting the dean causes her to not graduate. So she graduates or fails to graduate because of one of these two possible things, the insulting of the dean or failing two classes. So that's the full statement there, and that's correct, Brendan, for sure. So even though you said it was hard, you seem to have gotten the right answer, which is great. So question 18, not much else I can say about that one for the moment. So we go on into the next section, okay? So the next section involves truth tables, translation, and then the question is whether these two statements are logically equivalent or not. So the first step of question 19 is that you have to designate the translation and do the sentence letters. So let's erase here and get that part done. Okay, so what letters must be used? B, Bill goes to the party, so this is question 19. Okay, and then C, Calvin goes to the party. All right. Now, just the translation of the two sentences, first of all. One says, if Bill does not go to the party, then Calvin will not. So how can that be stated in logic? We have just the two letters, B and C. And I need to use those plus connectives to frame, if Bill doesn't go, then Calvin won't. So what is that? Okay, so if not B, then not C, exactly. Okay, now what's the other one? The other one is that if Bill goes, then Calvin will. So what's that second one? B, then C, good. Okay, now, what are the main connectives of those two statements? The main connective of the left sentence and the right sentence are what symbol? The main thing connecting all the pieces in the two statements here. It is the arrow, not the tilde, no. This one doesn't even have a tilde, so maybe you're thinking that over here it's a tilde, but no, because this tilde is not occurring outside of parentheses, so it's not negating the whole formula. It's just negating B. But this negation is connected to the right-hand negation by means of the arrow. So this is the thing that connects all the parts together. That's why it's the main connector. Same here. It's the only connection, so that's easy. Now, we have a truth table to construct. Up here on the top left is where we list the alphabetic order of the letters, and it's BC. In case there are two sentence letters, the required number of rows is how many rows? 4, exactly, right. So there's 2 letters, there's 4 rows. 3 letters, there's 8 rows. 1 letter, there's 2 rows, and so on. So starting with 1 as the base case, where there are 2 rows, with each additional sentence letter, we just double that. So when there are 2 letters, there's 4. When there's 3 letters, there's 8. If there were 4 letters, it would be 16, and so forth. So this requires 4 rows. Now, underneath the leftmost letter in the key, the top half of the values given are T's, and the bottom half F's. So yes, it would be T, T, F, F. And then just to the right, this column underneath C is T, F, T, F. So as we always do, when you have a truth table and you've provided the truth value assignments on the left here, we simply mirror that by placing the values underneath each letter that occurs in the formula. So underneath every case of B, we write that display of T's and F's underneath. T, T, F, F. And underneath each case of C, we have this order to replicate. T, F, T, F. Okay, now, we save the main connected for last when doing a truth table. So that means that let's continue by doing the negation signs on the left of B and C here. Okay, so this negation is attached to B. And we see the value that B receives in these 4 assignments. So the tilde to its left is simply going to reverse the original truth value of B. So then what shall be written here? Blank, 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 going down underneath tilde. Okay, good, Ruby. It's FFTT. Likewise, in this case, the tilde that's to the left of C, what is the order of those 4 things? Good, Ruby. I see you're already getting to it. FT, FT. Now, with these on the left and these on the right, underneath the 2 tildes, we'll use those truth values to assign what's given underneath the arrow in the 4 rows. So let's go row by row. In row 1, what's the truth value here underneath the conditional sign in that space? Row 1. True. Good. Because it's F, F, which yields the value true. In the second row, in this space, what's the truth value to place? Good, Evelyn. Also true. Because it goes from F to T, which according to the rules for conditional is a true conditional. How about the third row in this space? What's the truth value of the conditional there? Okay, good, guys. That's the one that's false, exactly. Because in that row, T is on the left and F is on the right, which yields the truth value of false. And that's the only combination on left and right that makes the single arrow conditional a false conditional. Finally, in the 4th row, here, what's to be written? 4th row also is true, exactly. Because it's true leading to true. And also you can just think of it like this. It does not say T leading to F. So in all of the cases, it's a true conditional. So here, that's done, and we circled it. Now, over here, 4 blank spaces. In row 1, what's the truth value on that conditional to the right? B, then C. Row 1, the truth value to write down is which letter? T. Good. Second row? Row 2, F. And then row 3 and row 4. Row 3, true, yes. And row 4, also true. Good. So now we circle here. And there's still one question. We've reached almost the tail end, but we have this question still. Are the 2 sentences logically equivalent or not? Are they? Or are they not logically equivalent? You'll tell me. Equivalent or not equivalent? Okay, good, Evelyn. Not logically equivalent. Also, Stephanie, good, correct. So they're not equivalent. No, that's exactly right. Which rows show us? Which row or rows show us that these are not logically equivalent sentences? 2 and 3, exactly. Because looking at row 2, they do not match. It's T here, it's F there. That's not a match. And if there's even one, all right? Also, row 3 is another case which shows us the same thing. F here, T there. So they're not equivalent. When you finish a pair of sentences in a truth table, and the question being asked is, are they equivalent or not? When the table is complete and the 2 rows have been circled, or the 2 columns have been circled, you go through them row by row and inspect, is there any horizontal row where they don't have the same truth value? And in this case, there's 2 such rows, which means they're not equivalent. Not equivalent sentences. So if you have this in your answer, as you see it here, then that would be 20 points on this question. There's a few components to getting the question right. One part is doing the translations correctly, setting up the truth table correctly, and then giving the right answer as to whether they were equivalent or not. Okay? And so some combination of partial credit's possible if you got some of that, but not all. But that would be the correct answer on number 19. Okay, and so we just have the one more problem. What if you put parentheses around the translation? You mean like on it, like this or something? Is that what you're asking? That's fine. It's not necessary, but it's not a problem either. So yeah, that would be okay. Mm-hmm. Okay, so good. Number 19. We're all done with this one. So last but not least is 20. All right, so question 20 is a big, long, individual sentence. And it's just asking you to create a truth table which will show if this is logically true, logically false, or logically indeterminate. So, question 20. So there's no translation or anything like that, no symbolization going on here. We just have a big, long sentence. So I'm going to write it out as we see it on the page. So M or not M, if and only if not N, then N. Let's use the double arrow, I guess, sorry. Just because I'm sure that a lot of you did, so it'll look the same here as it looks in your work. And not N, then N. Sorry to do this, but I want to slide it over to the left a little bit. Okay, so let me just start that one last time. Okay. M or not M. If and only if not N, then N. Or if N, then K. Okay, so question, what's the main connective here of the full formula? What is the main connective of the big thing? The wedge, exactly. Which one, though? There's two of them that occur in the formula, so it's which one, the left or the right wedge? It is the right-hand wedge, exactly. It's this symbol here. It's a big disjunction. The left disjunct of the disjunction is a biconditional statement. The right disjunct of the disjunction is a conditional statement. So this disjoins the left and the right side of the big formula. Now, there's three letters that occur here. There's M, N, and K. So how do those go alphabetically? KMN. So 3 sentence letters requires a total of how many rows then? 8, yes. So to the leftmost row, or I should say column. Column is vertical, row is horizontal. So in the leftmost column here underneath K, we have 8 entries, and the top block are T's and the bottom block are F's. So it's T, 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 F, 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 F here. Underneath M, it's the 2x2 pattern. Because the rule is that with each successive additional column, the rate of alternating with T's and F's doubles with respect to the previous column. So 4x4, 2x2, 1x1. TF, 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 TF. And again, there's a specific reason because this displays all combinations possible of the 2 available truth values assigned to the letters in the formula. Okay, so as we always do, we have to now replace the truth values underneath each sentence letter in the order given in this table. So wherever you see an M, there's a 2x2 downward display of T's and F's. Okay, here's another case of M. Okay, now when there's an occurrence of the N, it's a 1 by 1 display going down. So here there's 3 of those. T, F, T, F, T, F, T, F. Okay. Another case of N, F, T, F, T, F, T, F. Okay, and then one more N. Okay, and then over here finally K, which is the one situation of 4 by 4 column. Okay, sorry, it's a little scrunch there at the tail end there, but hopefully that's visible, and it will be when you watch a replay. Okay, so this is the main connective, so this is not going to be filled in here to the very end. So we can now just go in whatever order we want. Let's do the conditional over here, because that's pretty simple. So 8 truth values to place in these 8 blank spaces. Row 1, what's the truth value there? Row 1, it should say what? Or how about this? Let's work backwards. Huh? In which rows here is the value F? Show me in the chat where I should write the letter F in this sequence of 8. In which rows, if any? Row 5 and 7, correct, because those are the only 2 cases where T leads to F. Row 5, that's this one. Row 7 down here, that's this one. But in all the other 6 cases, you don't have that combination, so everything else, therefore, is true. Okay, so that's now done. Now, before we do the biconditional, which is interior to this big bracketed expression, we have to handle the things on the left and right sides of it. Okay, so let's do this side first. This is a disjunction of M or not M. And so this tilde here has to first be evaluated on the left of the right disjunct. So tilde simply flips the value assigned to its immediate component. So give me then the range of values starting in the top of this column going down in these 8 blank spaces. What shall it say? Good, it's 2 by 2 starting with F's instead of T's. So F, F, T, T, F, F, T. Okay, good. Now the only remaining task on this part is to fill in the disjunction column. Okay, so with disjunction, if you remember the rule, it's true in every case unless both the left and the right side are false disjuncts. So is there any row here where you see 2 F's, F on the left and F on the right under the tilde? No, there's no such row. So that means they're all the letter T here. 8 T's. All right, so that part's all good. Over here now, this is a conditional. The antecedent of the conditional is the negation of N. And with N itself, it receives these 8 truth values in the 8 assigned rows. So this tilde then is simply going to reverse the value assigned to N in these 8 cases. So now underneath tilde going down, what is the ordering of the 8 truth values there? Good, so it's the 1 by 1 FT pattern. Okay, now all that remains in this part is to do the 8 things that fall within the space underneath the arrow, the conditional sign. So we're looking at tilde and the value underneath N. Now, is there any row where you see T leading to F? If so, which ones? Which rows underneath that arrow shall we write F in? 2, 4, 6, 8. Okay, good. 2, T to F. Good. 4, T to F. Also good. 6, T leads to F. And also in the final row, T leads to F. Now in all the other 4 cases, you don't have that particular combination, and that leaves us with T. Okay, now it's biconditional time. Now this biconditional requires that we look at what's underneath the wedge, this column, and what's underneath the arrow, this column. And the rule for biconditional statements is that they are true if you have matching truth values on left and right. So it's true when there's 2 T's or 2 F's. But if they don't match, then it is false. So how about row 1? T, T. What's that in row 1? True. Row 2, T, F. Okay, good, false. Row 3, T, T. True. Row 4, T, F. False. Row 5, T to T. True. And then 6, we have T here and F here. False, good. Row 7, true paired with true. Okay, good. That's true. And then in the 8th and final row, we have true T paired with F. So 8 is also F. Good. Now, we finally reached the ultimate stage where we fill in under the main connective at last, which is this disjunction sign. Now, with the disjunction, it's going to be true unless you have F's on both sides. But if there's even one letter T on either the left or the right, then that suffices for it to be a true disjunction. Okay, so here in this row, what we look at is the double arrow value and the single arrow value over here. And if we see anything that's the letter T, we're done, and we could just write true there. So in row 1, what's the value to write underneath the wedge symbol? Row 1. True, good, Lily. Because of the fact that there's 2 true disjuncts. So that's twice as much that is needed to make it true. In row 2, what's underneath the wedge? Also T, yes. In that case, it's because of the right disjunct, this one. Never mind that the left one says F, because with this wedge sign, only one has to appear as true for the whole thing to be true. So row 3 now. What's the value of row 3? Also true, because there's double T's on both sides. Row 4. Row 4, true. Because of which disjunct? The one on the left or the right? Question there in row 4. Which disjunct makes it true? Good, Lily. Just so that I make sure we're tracking the fact of the reason here. It's because this disjunct shows true. So the whole disjunction is true for that reason. In row 5, what's the value of row 5? True again. Based on which disjunct, left or right? The left one this time. This guy right here, okay? And then in row 6, what's our truth value? True, good. And that's because of this disjunct, the right-hand one. What about row 7? True, yes. And it is because of this disjunct on the left. And then finally in row 8, true again, yes, for the fact of this disjunct on the right, which is true. So now we can circle the main connected column. And now our question to be answered, this one sentence, is it logically true, logically false, or is it logically indeterminate, this sentence? It's logically true, exactly. It's logically true because the circled column under the main connective displays 100% T's. Had these been all F's, then that answer would have been that it's logically false. Had there been a combination of both T's and F's underneath the main connective, then the answer would have been that it is logically indeterminate. But this particular question and proposition in logic is logically true. So there you have it. That would be the correct answer for number 20. And if you have that displayed in your submitted exam, then that's 20 more points right there. And of course, there's potential for some partial credit depending on if there were errors and what they might have been. But that's it. I wanted to take today to review the exam, but I'm also going to send a copy to all members of the class of the answer key so that you can still look at those answers and review them together in conjunction with the recording of this review of the exam and the answers. So I guess, therefore, we will really start on the next major topic of the class on Wednesday. Today was just getting us all clear and set on the right answer for the midterm. When we return on Wednesday, we're going to start looking at Chapter 5. So I invite you guys to read the pages in Chapter 5.1 and at least try to think a bit about how to do these derivations. Then I'll make sure to clean up and explain it in much more depth on Wednesday, and that'll be our sole focus for the whole rest of the semester. I'll also assign for you guys the next following homework assignment later in the week. I want to do that after I finish sorry, I see your question, Jessica. I'll get right to that. I want to finish grading your midterms this week, and so I'll deliver the instructions for this third homework assignment later in the week, and you have about 2 weeks to do it. The third one is going to combine truth tables and symbolization questions like what we have done on the past few weeks on truth tables. There was no questions about that on the second homework, so the third homework has some truth table questions and also some translation stuff. Now, Jessica, is it fine if we didn't get to answer a question in the exam? Yes. I mean, if you didn't answer it at all, then you wouldn't get any points for it, but that doesn't mean that you won't have credit for all the other stuff you did in the test. It's not like I would be that punitive to just not credit someone's whole exam just for 1 or 2 missed answers. So yeah, no, I mean, I want to give you as much credit as I possibly can. When you leave something blank, of course I can't give you anything for that blank answer, but it won't affect the score of any other questions. That's what you need. Okay, good. So other things on your mind or anything else? We've reached to the end of our session today, I guess. But it's productive and helpful, I think, for you guys to get clear on the recent work that you submitted. So I guess other than that, well, yeah, just as always, I like it when students come to me for their scores so that we can discuss them a little bit at least, and I can give you some direct information on your particular corrections. So I like it to be individualized, yes, but when I have finished the midterms, as I will in the next few days, then I'll send a notice for everyone that wants their score to just check with me and then get it. And they can also, if they haven't done so, check for any of their other scores too on the previous assignments or in the class overall. Okay, so what we're looking at as the class continues are 2 more homeworks and the final exam. And if you just keep coming to class, reading the text, doing some practice problems, and following closely, I think you'll be good to go. But I'm here to help anybody else throughout the semester. What were the extra credit opportunities throughout the semester? I didn't have any in mind, but I may make a decision to offer some later on. Let me think about that question, and if I can find a way, I would like to do that. One thing that I would like to do to offer everyone extra credit, actually, because I've done this in the past when we had an election year, is if you can send me proof that you voted, I'll give you extra credit points just for voting, because the real world significance of being a good critical reasoner is that you're actually able to understand arguments and process information and come to correct conclusions. So one of the practical benefits of that is the act of voting. Now, if you're not 18 yet, emailing me a pic would be the way to do it, Brenna, for sure, with your sticker. When you have a mail-in ballot, Leonard, you still get the sticker. I just sent mine in on Saturday, and that would be what I would ask for, But anyway, yeah, just some proof. So I can't just take people's word for it, so I just need some kind of verification of it. But if that happens, and I'll send a note which gives you more detail, like how many points, but I was thinking 5 to 10 points or something. If you've already turned in your ballot, Brenna, then I guess I'll have to devise an alternative for those that have. But that's one idea. You asked about extra credit, and I'm just telling you thoughts that I had. I was going to mention this during the message that I sent you later in the week, but I guess we are getting pretty close, and we have historic early mail voting happening because obviously the pandemic, and people want to make sure it's counted. So we'll devise a fair way that everyone can get their credit, whether they voted or not. But for those that have not yet voted, capture proof of your voting act, and if you can forward it to me, then I'll be willing to give you some number of points, but no more than 10, maybe no less than 5, something like that. You know what I'm saying? And I'll see you guys on Wednesday, yeah? Thank you. I'm going to discontinue the Zoom stream, and then I'm going to stop the YouTube lecture as well. So here, we're ending Zoom. Thanks again, everybody. Okay. And to the YouTube crowd, here we go. See you guys. I'll see you next time. Have a good one, and stay safe and everything else. Bye-bye.